In studying pharmacodynamics principles of drugs, it is important to understand that each drugs have specific way to interact with the body producing an effect. Meaning, each drug has its own specific mechanism of action to produce an effect or to cause a unique response to the body. Now, when we talk about mechanism of drugs action, in general, there are two major mechanisms of drugs action. Pwede ang isang drugs action is a target protein mediated, or a drugs action may be non-protein targeting or non-target protein mediated. Now let us have first target protein mediated. When a drug's action is target protein mediated, it means that a drug has to bind to the active site of protein, producing an effect or producing a unique response. Say, for example, of these proteins where a drug binds are structural proteins, or they can also bind to the active site of a regulatory proteins. When we say structural proteins, these proteins, they are the ones that form cell framework. These are very important for cytoskeleton. Based on the root word itself, these proteins are very important for the cell skeleton, diba? Structure. It's very important for cell skeleton. It composes the structural elements. Example, structural elements in the cartilage or in the bones. Okay, thus maintaining the structure, maintaining the cell shape. So example of a structural protein is tubulin. Another is the microtubulin. And I have mentioned last meeting that these tubulin is very important for cell movement. Aside from cell movement, we also have microtubules, very important for mitosis. And others are very important for axonal movement of neurotransmitters. Okay, these are a few of the most common functions of this specific structural proteins, tubulin and microtubules. Now, there are certain drugs that could target these structural proteins. An example is colchicine. Okay, recall that colchicine, the mechanism of action of this drug as an anti-gout is that it causes depolymerization of the structural protein tubulin. Now, since tubulin is an example of structural protein, then colchicine is an example or specific example of protein targeting drug. Meaning, isa siyang gamot that has to target a protein, that has to bind to the active site of protein in order to produce an effect. Aside from colchicine, another example of drug that targets structural proteins, we have the vinca alkaloids, or particularly vincristine. Again, the vinca alkaloid, particularly vincristine, Another drug is the paclitaxel. Paclitaxel. This is usually sold out or sold under the brand name Taxol. And vincristine and paclitaxel, specifically, these are anti-cancer agents, or they are considered as anti-neoplastics. When you say anti-cancer drugs, anti-cancer agents, they are also termed as anti-neoplastics. Now, with regards to their specific mechanism of action for vincristine and paclitaxel, for their mechanism of action as an anti-cancer agent, these two are said to target microtubules. Again, these two anti-cancer agent, they are said to target microtubules. Now let's have a short explanation why these two agents can be used for cancer chemotherapy, given only this idea that both are antimicrotubule agents. So let us start with the common property of a cancer cell. Okay? Ano ba yung property ng isang cancer cell? Ano yung relationship niya sa microtubule? Now, basically, when we talk about cancer cells, when we talk about cancer cells, they have that property to reproduce rapidly. No, they like to divide rapidly in our body. They undergo rapid proliferation. And to one way in our body of cell division is the process called mitosis. Tama? I know you're familiar with this term. Again, one way of our body of cell division is the process called mitosis. Alright? So just like for our normal cells, mitosis is an important stage in the development of cancer cells. And one important structural protein, one important structural protein involved in the progress of mitosis are the microtubules, as mentioned earlier. Very important for mitosis. Now let us go back to the mechanism of action of vincristine and paclitaxel. Again, these agents are anti-microtubules. They are anti-microtubules, meaning they somehow target these microtubules, which is very much involved, very essential for the progress of mitosis. So targeted ang microtubule, thus inhibiting mitosis. Kaya therefore, pigil ang cell division process ng mga cancer cells. That is why vincristine and paclitaxel are classified as anti-cancer agents. Alright? So this is the reason why these agents are protein targeting. Kasi again, they target a structural protein, particularly microtubules. Now let us proceed um, to another class of proteins, okay, wherein drugs may be considered as protein targeting as well. So this time, they specifically target another class of protein, and these drugs target regulatory proteins. Now, from the term itself, regulatory, so from the word regulator, so these proteins particularly regulates cell activity, or these proteins somehow regulates cell functioning. Basically, there are four types of regulatory proteins. These are the voltage gated ion channel, the carrier molecules, enzymes, and receptors. Now, let us have first the voltage gated ion channels. Example, we have um, sodium ion channel, we have the potassium ion channel. Another example is the calcium ion channel. Now, to give you an idea about these ion channels, we can actually define it based on the term used, based on the term or the type of the regulatory protein itself. Voltage gated ion channel. Kapag sinabi nating channel, ayan, when we say channels, it implies a passage, kumbaga daanan, di ba? So these are channels particularly that are usually embedded in cell membrane. Say for example, this is a cell membrane. This is the outside of the cell and the inside of the cell. Then you have an ion channel. So it is embedded in cell membranes. Ang tanong, ano ba yung dumadaan sa passage na ito? Sabi dito, ion channels. How do we define ions? Well, when we define ions, these are charged atom. So example doon, sodium ion, potassium ion, calcium ion, etc., etc. Okay, that is why we have these examples of channels: the sodium ion channel, potassium ion channel, calcium ion channel, specific examples of ion channels. Now let us extract one example. We have sodium ion channel, for instance. For example, this is a sodium ion channel. Now, naalala ba yung mnemonics sa basic chemistry na piso? Naalala ba yung ibig sabihin ng piso? Recall that this abbreviation means potassium in, sodium out. Again, potassium in, sodium out. Meaning, in normal condition of the cell, meaning sa normal condition, meaning resting state of the cell, sodium ions are found outside of the cell. Okay, outside of the cell membranes on a resting state of a cell. Now, whenever These cell, this particular cell from its resting state becomes stimulated, meaning equivalent anang stimulated, meaning the cell becomes depolarized. Depolarized meaning the inside of the cell becomes positively charged. Okay? Again, whenever this cell from resting state becomes stimulated, becomes depolarized, then automatic this channel, the sodium ion channel, it will open. Okay, so it will open from close gate. Okay, from its close passage, it will open, letting the sodium ion enters the cell. Right. So that is how a voltage gated ion channel works. An ion channel that opens transiently in response to a voltage. Okay, in response to a cell after depolarization. Now, for the drugs that targets a voltage gated ion channels, few of them will be introduced under central nervous system drugs, but mostly uh, those drugs that targets these ion channels will be tackled more in pharmacology too. So that will be next semester. So utang ko muna yung mga detailed na mechanism of action ng mga drugs. Alright? So I will just give you a list of common examples that targets a sodium ion channel, drugs that targets a potassium ion channel, or drugs that target a calcium ion channel. So let us have first sodium channel blockers. Okay. So una, we have the sodium channel blockers. So obviously, these drugs blocks the sodium channel. It blocks the sodium channel or ion channel. So example of a drug, class of drug that are considered sodium channel blockers. We have the local anesthetics. Okay, the local anesthetics. In your Pharm Chem 2 medicinal organic chemistry, you will discuss, you will also be introduced to be exposed with local anesthetics, but we will also tackle this under CNS drugs. This is part of our course outline. But in your PChem 2, you will get to realize that local anesthetics has two types based on its chemistry, based on its chemical structure. We have first local anesthetics that are ester type, meaning in its structure it contains ester structures. Second, we also have local anesthetics that are amide type. Okay, amide type. All right. An example, specific example of a local anesthetic that is ester type is benzocaine. Okay, benzocaine. Example of an amide type local anesthetic is the lidocaine. Ayan, lidocaine. Yung palatandaan ko before, in order to distinguish if it is an ester type, an amide type, local anesthetic, I will just count the number of letter I in the word or in the name of that particular local anesthetic. Usually, usually if you check if you check the list of local anesthetics that are ester type, they only have one letter I sa name ng drug. Whereas sa amide type naman, mostly sa mga local anesthetic, name of local anesthetics amide type, dalawa yung letter I niya. Okay, so yun yung palatandaan ko before. But hindi naman lahat. Pero mostly, ester type, isa lang yung letter I. Amide type, dalawa yung letter I. Alright? We also have drugs that targets potassium ion channel. So, meron din tayong tinatawag na potassium channel blockers. Okay? So, potassium channel blockers, example, we have the class 3 antiarrhythmics. So, this will be discussed under cardiovascular drugs, pharmacology 2. So, utang ko muna yung detailed mechanism of action nito. We will all discuss this, okay, along the journey in pharmacology. Then, secretagogues, okay, those agents that triggers the release of insulin from the uh, beta cells of the pancreas. Okay, example are those sulfonylureas. The sulfonyl ureas, madali lang natin ma-identify via its name if it is a hypoglycemic agent. Those with a prefix gly or gly with letter I. So example, glimepiride, glyburide, what else? Glipizide, glibenclamide, so ayun. Those are example of sulfonylureas. They are considered insulin secretagogues. And generally, they have that mechanism of action by blocking potassium ion channels. And lastly, for calcium channel blockers, we have, ayan, for calcium channel blockers, we have two classes. Again, based on its chemistry as well, based on its chemical structure. We have the dihydropyridines. The dihydropyridines, kindly check over the internet what is the spelling, ha? Dihydropyridines. We also have the non-dihydropyridines. So these two classes are based on the chemical structure of the drugs, calcium channel blockers. By looking at its name, we can also easily distinguish if a CCBs is a dihydropyridine. Those ending in dipines, okay, those with a suffix dipines, they are dihydropyridine type of CCB. Specific example is amlodipine. Diba? Amlodipine. Alright? For non-dihydropyridines, we have only two. Most common example. We have the verapamil and the diltiazem. Alright? So these are the examples of drugs that targets a voltage-gated ion channel. Alright? So, kung babalikan natin yung general action nila, all these drugs are considered protein targeting Okay, protein targeting kasi they are able to target a voltage gated ion channel. And a voltage gated ion channel is a type of regulatory protein. So protein targeting sila lahat, right? Now let us proceed to another type of regulatory proteins. Uh, we also have the carrier molecules. Okay, so I have mentioned in our previous discussion what these carrier molecules are. Recall that these are cell membranes, diba? Cell membrane proteins to be particular. Okay, so these are also proteins that are embedded in cell membranes. Okay, again, these are cell membrane proteins with specific binding sites, and whenever a particular endogenous or exogenous ligand bind to its site, it will undergo conformational changes. So example is the hydrogen potassium pump, or this is also known as the proton pump. All right, so again, an example of carrier molecule is the hydrogen potassium pump, or this is also known as the proton pump. So no problem with the physiological function of this particular carrier molecule because we had a detailed discussion about this last meeting, right? And recall that the class of drugs that targets proton pump are what we call the proton pump inhibitors, or the PPIs. All right. So specific examples of proton pump inhibitors, those ending in prazoles. Okay. So we have omeprazole, esomeprazole, what else? Pantoprazole, lansoprazole, ayun. So meron lang exception, except aripiprazole. Okay, so except aripiprazole. Right? Kasi yung aripiprazole, isa siyang antipsychotic agent. Okay? So, same with ion channel blockers kanina, proton pump inhibitors are also protein targeting. Okay? Protein targeting drugs din sila. Kasi, it specifically targets a carrier molecule. And a carrier molecule is another type of regulatory protein as well. Now, another type of regulatory proteins, aside from carrier molecule, we have the enzymes, right? Now, if you recall in your biochemistry, when we encounter enzymes, we usually define this group of proteins as biological catalysts. Okay, so again, enzymes in general, these are biological catalysts. And what are specific examples of enzymes? Ang dami. Sobrang daming enzymes available in among living species. I'll just give you a specific example of enzymes. We have the phospholipase A2, yung na-mention ko na para madali na lang yung pagpasok ng gamot. We also have the cyclooxygenase. We also have the lipooxygenase. Alright? So particularly, all these enzymes are involved in the COX and LOX pathway. Diba? Involved sila sa metabolism of arachidonic acid. Okay, so that is partly involved with a COX and a LOX pathway. And there are drugs that could target the enzymes involved in that pathway. Examples, we have drugs that inhibit, for example, the enzyme COX. All right. So we have drugs that could inhibit the enzyme COX, and that is NSAIDs, the non-steroidal anti-inflammatory drugs. Right. We also have an agent that inhibits the lipoxygenase enzyme, and we have Zileuton. Okay. And we have steroids that targets mm, phospholipase A2. Okay. So all these drugs targets a particular enzyme. Okay. And enzymes in general, they are said to be regulatory proteins, thus making these agents be classified as a protein targeting drugs. All right. And finally, um, we have the last type of regulatory proteins. Okay, and these are the receptors. So I believe um, everyone is already familiar with the term receptor. Siyempre, tapos na kayo, di ba, sa biochemistry. So, somehow may knowledge na kayo on the relevant concepts that describes a receptor. But recall that when I say receptor, pag sinabing receptor, these are protein. It is a functional protein that are again embedded in a cell. Okay? And usually, yung isang receptor, meron yang active site. Meron siyang specific stereochemical configuration where a ligand usually interacts. Diba? And paano nag interact yung ligand and receptor? Diba? They usually interact in a lock and key fashion. Okay? Now, talking about lock and key fashion, yung nagsisilbing lock dito is yung receptor. The key is yung ligand. Okay? Producing the receptor ligand complex. Alright? Now, for most of the drugs that will be discussed in Pharmacology 1, most of them are receptor targeting drugs. Sobrang daming gamot available in the market that targets a specific receptor. So, bago natin aralin yun lahat, yung mga gamot na yun that targets their particular receptor, it is very important to build first our knowledge on the concept of receptors, including the different types, no, or different families of receptors. So we will have a separate detailed discussion about receptor, including its major types. So we will have that on the next few slides, including the common class of drugs, examples of drugs that targets each type of receptors. Okay? So utang ko muna ulit yung part na ito. But don't worry, discuss natin to lahat right after we finish our discussion on this topic about mechanism of drugs action. Okay, so right after we finish this subtopic about mechanism of drugs action, then we will proceed immediately to the concept of receptors and its major families. So overall, these are the four types, no, of regulatory proteins. Again, we have the voltage gated ion channel, the carrier molecules, enzymes, and receptors. So that is all for the mechanism of drugs action that are target protein mediated. Okay, so this time, let us proceed to the other way, how the drug interacts with the body producing a response. So on this slide particularly, um, we will talk about drugs action that is non-target protein mediated. Okay, so again, yung focus naman natin on this slide are those drugs action that is non-target protein mediated. Ibig sabihin, no binding to an active site is required in order for a drug to produce an effect. So there is no involvement of a protein this time. Okay. Now there are three possible mechanisms for a non-protein targeting drug to produce an effect. Example, we have colligative mechanism. Okay, so via colligative mechanism. Another is through direct chemical interaction. And finally, we have the counterfeit mechanism. Again, ito yung tatlong possible ways how a drug mediates its effect or produce its response even without binding to an active site of protein. So let's have first via colligative mechanism. Okay. So in colligative mechanism, based on the term itself, meaning yung way ng drug to produce its mechanism of action has something to do with colligative property. And what is an example of a colligative property of a substance? Diba? Example of a colligative property of a substance, of a solution, for example, is osmotic pressure. Diba? Osmotic pressure. Now, talking about osmotic pressure, this is very much related or very much relative to the principle of osmosis. I believe you are all familiar, okay, to this term osmosis. Okay, familiar na ang lahat sa term na osmosis. Okay, osmosis has something to do with the movement. No, when you say osmosis, it has something to do with the movement of solvent. What is an example of solvent? A universal solvent, for instance, water. Diba? Movement of water mula an area with a low concentration to an area with a high concentration. Okay? When we say high concentration, we're talking about here the concentration of solute. Okay? Ayan. So again, osmosis, this has something to do with the movement of a solvent. So example of a solvent is water. Paano yung movement ng solvent, ng water? From a concentration with low solute to a higher concentration. Now, what is an example of a drug that acts acts via colligative mechanism or via this property, osmosis. An example of a drug that acts via this mechanism is the drug mannitol. Okay, specifically, mannitol is used as an osmotic diuretic. All right. When we say diuretic, when we say diuretic, nagpapaihi. Okay, isa siyang gamot, may it be solution, okay, solution form, parenterally administered or orally administered. Pag sinabing diuretic, nagpapaihi. Okay, so with mannitol, particularly, yung ginagawa niya, it draws out water. Okay? Nagdo-draw out siya ng water molecules. Okay? Mula sa blood, from the blood, going to the urine via osmosis. Okay? Again, with mannitol, yes, nagpapaihi siya. Isa siyang diuretic. Particularly, yung ginagawa niya, nagdo-draw out siya ng water molecules mula sa blood papuntang urine via osmosis. Okay? So basically, this drug will be discussed under cardiovascular agent. Okay, so yung mas detailed talaga na discussion about this mechanism of action of this drug will be presented sa Pharmacology 2 next semester ulit. But now, at least you have that general idea already how mannitol works in the body. So again ha, mannitol is an example of a non-protein targeting agent. Non-protein targeting drug. Okay, balikan ulit yung action niya in the body. Diba sabi natin, osmotic diuretic siya. It draws out molecules, water molecules via osmosis. So obviously, there is no involvement of binding to an active site of protein. Mainly, its action um, only involves colligative property, and that is mainly osmosis, principle of osmosis. Okay? So, isa siyang osmotic diuretic, mannitol. Now, let us have another way of drug action without binding to the active site of protein. So we have via direct chemical interaction. Okay, so an example of chemical reaction is neutralization. Diba? Recall that neutralization is an example of a chemical reaction. Right? Particularly in this chemical reaction, we have an acid being reacted to a base. Again, this is a chemical reaction between an acid and a base. So what are example of drugs na yung mechanism of action niya is via neutralization? Example, we have the drug antacids. Of course, we are all familiar with antacids, antacids. Okay? Para saan ba yung antacids? Antacids for hyperacidity. Okay? So obviously, acidity. So obviously, for the management of hyperacidity siya ha. So during neutralization, these substances, specifically yung antacids, they act as bases. Diba? They are able to counteract, they are able to neutralize the stomach acidity. What are examples of antacids? Examples, we have the the Kreml S, we have Maalox. Kreml S plain and Maalox, they have the same generic names. It contains both aluminum hydroxide, the magnesium hydroxide, and the simethicone. Right? So another example of a drug or a substance that acts via neutralization reaction is the sodium bicarbonate. Okay? Mainly, this is used for the management of metabolic acidosis. Ano ba yung underlying cause why there is uh, a problem arising like metabolic acidosis? An underlying cause why this problem on metabolic acidosis arises is that there is a lowered level of bicarbonate ion. Again, usually yung underlying cause bakit merong metabolic acidosis, yung problema is mababa yung bicarbonate ion. Okay? And bicarbonate ion is a basic ion. Alright? Therefore, physiologically, kapag mababa ang basic ion na to sa katawan, mababa ang bicarbonate ion sa katawan, acidotic environment will dominate. Kasi mababa yung basic ion. So, magdo-dominate yung acidotic environment. Now, to manage this condition, sodium bicarbonate can be used to neutralize the rising acidity that is being caused by lowered bicarbonate ion level. Alright? Another example is protamine. Okay? Protamine is also an example of a drug that acts via neutralization reaction. Protamine, specifically, this is commonly used for heparin toxicity. Alright? So, so I will write the chemical reaction. Protamine, it will usually act as the base. Okay? Again, in the chemical reaction, protamine acts as a base. Okay, this is based on the name of the substance itself. We can expect, di ba sabi, protamine, via looking at its name, clue na yan, na isa siyang base. Because we can expect na by chemistry, by chemical reaction, it contains amine. Di ba? Meron siyang amine sa suffix part ng root name niya. And recall that in chemistry, basic chemistry, pag ang substance, ang compound, merong amine structure in general, they are considered basic in property. They are said to be bases. Okay? So, vice versa, in return, yung isang substance na kina-counteract ng protamine, which is heparin, siya naman yung nag-act here as acid. Okay? So obviously, this is another neutralization chemical reaction. Okay? Acid and base. So again these agents are considered non-protein targeting drugs. Kasi their way or mechanism to produce effect is via neutralization chemical reaction alone. So there is no involvement of a protein. Okay. Now, aside from neutralization, we also have another way of drug to produce its effect via direct chemical reaction. So example, we have via chelation. All right. So when I say chelation, we are forming here complexes, forming um, larger molecules amongst substances. So one example is during iron poisoning. Okay. So example ha, during iron poisoning, iron Fe poisoning. Di ba man say poisoning of a particular substance, ibig sabihin mataas, sobrang taas ng level or concentration ng particular drug na yan sa blood or sa serum. So for iron poisoning, sobrang taas ng iron level sa serum or sa blood. Now, a commonly used substance to lower the iron level in the blood is the drug deferoxamine. So I'll spell out deferoxamine. Okay, again, a commonly used substance to lower iron level is the um, deferoxamine. Okay, particularly with deferoxamine, kaya niyang i-lower yung iron level in the blood via forming complex structure with this iron metal, resulting to formation of ferrioxamine. Okay, so itong ferrioxamine, this is already an excretable form of iron. Okay, so non-absorbable form na to ng iron, deferoxamine. Okay? Now, para madali lang matandaan or kabisaduhin nyo, madali lang makabisado, no? Yung action ng deferoxamine, simply refer, directly refer or kabisaduhin nyo lang yung first two syllable ng word. Yung de, then fe. Okay? Again ha, para madali lang matandaan, kabisaduhin nyo lang ang name ng gamot na deferoxamine. Okay? Particularly, itong first two na syllable ng word. Take note nga for any root word that is being added with a prefix de. Okay? Pag may de, it somehow indicates removal of something. Okay? Diba? Pag de, merong tinanggal. Okay? Na ay remove. So in the case of deferoxamine, it counteracts iron metal. Okay? And an iron has a symbol of Fe. Okay? So, upon counteracting iron metal, it will then form Okay? So, kabisaduhin nyo lang yung term na deferoxamine de, removal of iron metal. Okay? Kaya nyong i-lower yung iron metal in the blood, okay, via forming complexes in the form of ferrioxamine, which is an excretable form of iron metal. So as observed, di ba, nagkakaroon lang ulit ng direct chemical reaction. There is no involvement of protein here. Okay? So purely chemical to chemical reaction. So again, Under direct chemical reaction, we have neutralization and chelation. Now, for the last mechanism of drug action without binding to the active site of protein, we have the counterfeit mechanism. Okay, counterfeit mechanism, this is also known as incorporation. Okay, the process of incorporation. Okay, now let us first define the terms used. Counterfeit. When we say counterfeit, uh, a synonymous word to counterfeit is false. Diba? Ibig sabihin ng counterfeit, false or fake. So, ibig sabihin, um, fake or false substance, isang fake or false substance will be incorporated sa body so that it will cause alteration of the normal functioning ng body system. So, a good example is or are the anti metabolites. Okay, anti-metabolites. Anti-metabolites in general, these are also classified as cytotoxic agents, meaning anti-cancer din. Okay, anti-cancer agents then. Again, these are cytotoxic agents or anti-cancer agents. And in general, anti-metabolites are said to be false metabolites. Okay? False metabolites, ibig sabihin, hindi sila totoo. Okay? Hindi sila yung natural metabolite na kailangan ng cell synthesis. Alright? Now, balikan natin muna yung cancer cell. Okay? Para ma-appreciate nyo naman, ano yung activity ng anti-metabolites? Ano yung counterfeit mechanism? Now, cancer cells ulit, okay? Cancer cells. Sabi ko kanina, yes, isa siyang cell na yung property talaga nila is they love to divide. They like to proliferate. Diba? Very important sa kanila yung mitosis process. Tama? No, ano ba yung important component ng isang cell? 'Di ba? Isa siyang cell. Ano yung pinaka-important component ng isang cell? 'Di ba DNA? Alright. Again, just like our normal cell, si cancer cell, since isa din siyang cell, important component din niya is DNA. Kaya, during cell cycle, diba, during cell cycle, very important na preparatory stage din ng cancer cell yung DNA synthesis. Very important yan. Now, in order to synthesize or form a DNA, which is a nucleic acid, syempre kailangan ng mga particular substances, okay, endogenous, natural metabolites that are needed in order to form a nucleic acids. Example ng mga natural metabolites na yon para mabuo ang isang DNA, para ma-synthesize yung DNA, are those nitrogenous bases ng nucleic acids to form a nucleotide. Diba? We have the pyrimidine. Naalala ba to? Pyrimidine bases, yung purine bases. Okay, so these are actually natural metabolites. Ito yung mga natural metabolites ng katawan. Purine, pyrimidine. Ibig sabihin, ito yung mga totoong metabolites that has to be incorporated sa DNA strand para makapag-synthesize ng DNA. And again, DNA synthesis, this is a very important preparatory stage among cancer cells as well. Okay. Now, we have a class of anti-cancer agents na ang ilahang mechanism of action is via incorporation. Okay, particularly incorporation of false metabolites. So those are anti-metabolites. Ibig sabihin, yung mga anti-metabolites, uh, they are being designed na ang model nila is yung mga natural metabolites. So example are the purine analogs. Okay? So yung structure niya kapareho ng purine. Example, the 6 mercapto purine. Okay? Another is the pyrimidine analog. The pyrimidine analog. Example, we have the 5 uracil. So again, these are false metabolites. Chemical compound with a molecular structure that are closely related to that of the natural metabolites. Okay? So, upon incorporation of this anti-metabolites, sabi nga, hindi sila yung totoong metabolites. Okay? Akala lang ng cancer cell totoo. So, kapag na-incorporate sila in the body, these anti-metabolites, ina-incorporate sa DNA strand, the DNA and RNA synthesis will be inhibited. Okay? Kasi anti-metabolites. So, hindi magpapatuloy yung DNA synthesis. Okay? So, akala lang ni cancer cell, yun na yung natural metabolite. Okay? Iba pala yung magiging response ng body. Kaya mapipigilan yung proliferation, yung cell division ng cancer cells. So that is all about count mechanism or on incorporation. Example are the anti-metabolites. We are incorporating here false, fake substances causing alteration of the normal functioning in the body system. Okay, and overall we are done with the different mechanisms of drugs action without binding to the active site of protein, thus considering them as non-protein